Welcome to my video for my Think Aloud for March 18th about our classwork on discontinuities and intercepts of rational functions. Discontinuities include holes and vertical asymptotes, and we're going to find those for our functions. We're also going to find the intercepts. Before we do that, though, we need to factor our rational function. All those good things come from the factored form. So that's my first task, is to factor this form of the equation. In my numerator, I'm going to start by factoring out a negative 3. You'll notice in my denominator I just have x squared. It's easy to factor if I just have x squared. So I'm going to try to get that in the numerator. So I take out my negative 3. If you'll recall, in our work yesterday, I factored out an x as well, because I had an x in both terms. Here I do not have an x in the last term, so I cannot factor out an x, but I can factor out the negative 3. And that leaves me x squared. Negative 3x squared divided by negative 3 is x squared. 3x divided by negative 3 is going to be negative x, because positive 3 divided by negative 3 equals negative 1. Negative 1x is x. 36 divided by negative 3 is going to give me negative 12. And in the denominator, I'll go ahead and factor the denominator into two binomials. I need x in both. One has to be negative, one has to be positive, because I need a negative number when I multiply them. When I add them, I need to get positive 1. So if I look at negative 6, positive 3, and negative 2 will give me positive 1x. 3x minus 2x gives me positive 1x. To factor my numerator, I'm going to say, still have my negative 3 times, now I'll have x and x. To get my x squared, I need one positive, one negative. So I will have positive and negative. And in this case, I need to multiply to get 12, negative 12. 1 times negative 12 would do that, but they won't add up to negative 1. So I'm going to try 3 and negative 4. That gives me negative 12. Negative 4x plus 3x gives me negative x. So I'm comfortable with that. X plus 3 times x minus 2. So I have my factored form of the equation. Why don't you guys go ahead and check the other problems, try to factor the other problems. You'll notice when you do problem number 3, that's a little difficult to factor. Sometimes you just can't factor. You only factor when you can. And sometimes you'll have a binomial, which you factor by doing the opposite of the distributive property. Sometimes you have two trinomials. Sometimes you have your binomial in the denominator. They're all different combinations. See what you can do with those, and then come back to the video. Okay, now that you've factored those, we can go ahead and try to find the points of discontinuity. So I will find my discontinuities. And that is where the denominator equals 0. I cannot calculate f of x if my denominator is 0, because I cannot divide by 0. My calculator gives me an error. So where will it equal 0? Well, if x equals 2, I get a 0. I get 0 in the denominator. That gives me a discontinuity. And that's actually going to be a vertical asymptote. We'll talk in a minute a little bit about why that happens. The other discontinuity is where x equals 3. And if I have my negative, if I have my 2, if x is 2, As I get closer and closer to 2, I end up with a very small number down here. When I divide by a very small number, I get a very large number. So this is actually going to approach infinity as I get close to -2. That's why it's a vertical asymptote. Asymptotes are where it gets closer and closer to the line, but never touches it. That's what happens when you're going toward infinity. If I look at x equal -3, though, as this gets close to 0, I have the x plus 3 in the numerator as well. That's going to get close to 0 as well. They're going to cancel each other out. So even though I have a discontinuity there, it's not going to infinity. The fact that I'm dividing by a small number and multiplying by that same small number prevents me from going to infinity. So this is what we call a hole. There's no value of the function there, but it's not an asymptote. Okay. Why don't you take a look at the other ones that you factored, see if you can find the discontinuities, and then identify whether they're vertical asymptotes or holes. Okay, now that you have found the vertical asymptotes and the holes, let's talk about the x-intercept. The x-intercept, just like with quadratic functions, linear functions, polynomials, the x-intercepts are where y equals 0. So I'm going to say that, or in this case f of x equals 0, equals divided by x plus 3 times x minus 2. We talked yesterday about fractions and how to make a fraction that is 0, fraction that's equal to 0. We decided that 0/4 was 0. So to get a fraction equal to 0, we need 0 in the numerator, which means one of these has to be 0. To get my discontinuities, I found 0 in the denominator. X-intercepts, I find 0 in the numerator. So if I look at this, first of all, it's tempting to say x equals -3. Gives me 0 in the numerator. But if I have x equal -3, I do not get 0 because I have my discontinuity. So even though that would make the numerator 0, it does not make the function 0 because the function does not exist there. So x equal -3 is not an x-intercept. If I had not had this down here, it would be. But since it's a discontinuity, it's not an x-intercept. My only x-intercept is 4. So at x equals 4, I have an x-intercept. And I'm going to go ahead and put that on the graph, because I know that's going to happen. Take a look at the other problems. See if you can find the x-intercept. In some cases, there may not be an x-intercept. If you look at some of these, it may not be possible to make the numerator 0. So if you just look at the other functions, try to find the x-intercepts. If you can't find one, that may in fact be the case. Okay. Okay, now that you've found your x-intercepts, let's talk about the y-intercept. I got my y-intercept. X-intercept is where y equals 0. Y-intercept is where x equals 0. And to get that, I'm going to go back to the original form of the equation. -3 times 0 squared plus 3 times 0 plus 36. And I'll divide by 0 squared plus 0 minus 6. And when you get used to this, you'll realize you're always going to have 0 wherever you have an x. You're always going to be left with this value, and this value. So my y-intercept is 36 divided by negative 6, which equals negative 6. So my y-intercept equals negative 6, where x is 0, y is negative 6. Take a look at the other problems, see if you can find the y-intercepts, and then come back to the video. Okay, now that you've found the y-intercepts, we are going to talk about finding the horizontal asymptotes. Horizontal asymptotes, they're not really asked for in the instructions, but they really help us in graphing the equation or graphing the function. So first of all, I think about what happens when x gets very large. So as x approaches infinity, I'm going to look at what happens, and I'm going to go to my factored form. As x approaches infinity, we'll say x is 1,000,000. That's a really large number, but it's not even close to infinity. But it's approaching infinity. From our perspective, it's approaching infinity. If I put 1,000,000 plus 3 here, I have 1,000,000 plus 3 here, they'll cancel. So I really don't need to worry about those. I have 1,000,000 minus 4 divided by 1,000,000 minus 2. 999,996 divided by 999,998. This number is going to be slightly bigger than this number. If I divide these, it's going to be just a little bit less than 1. Very close to 1. I'm going to get negative 3. As x keeps getting bigger and bigger, this is going to get closer and closer to 1. My y is going to approach negative 3. And if I look at as x approaches negative infinity, y is going to approach, well, let's look, a really large negative number plus 3. So negative 1,000,000 plus 3 divided by negative 1,000,000 plus 3, those are still going to cancel. Negative 1,000,000 minus 4 is going to be negative 1,000,004. Negative 1,000,000 divided by minus negative 2 is going to be negative 1,000,002. When I divide those two numbers, they're going to be very close to each other. I'm going to get a number that's very close to 1. I will have a negative number divided by a negative number, so it's going to approach positive 1. Positive 1 times negative 3 is negative 3. So when x gets bigger and bigger and bigger, this gets closer to 1, and my f of x gets closer to negative 3. So I'm going to say that's my horizontal asymptote. Because the function is going to approach that, but never actually touch that. It's going to get closer and closer, but these are always going to cancel. So I'm never going to actually get to y equals negative 3. Go ahead and take a look at the other problems. See if you can find the horizontal asymptotes. Okay, now that you've found all your horizontal asymptotes, you're ready to graph the function, except I want to do one more thing before I graph this function. I want to find this hole. There's a hole in my graph at some point. I know it's actually at x equals negative 3. So somewhere at x equals negative 3, I'm going to have a hole. I want to see where that would be. So I'm going to look at this. As x approaches negative 3, this is always going to be 1. It can never go to 0, but this is always going to be 1, just like we said before. So I'll say this is 1. And I'm going to get very, very close to negative 3. So this is going to be very, very close to negative 3 minus 4, or negative 7. Negative 7 here. Negative 3 minus 5, minus 2 would give me negative 5. So this is going to get closer and closer to negative 5. So I'm going to have negative 7 divided by negative 5 times negative 3. Or 21, positive 21 divided by negative 5. That's going to be a little bit more than 4. I'm sorry, negative 4. So if I go over here to x equal negative 3, I'm going to have a hole at negative 4. My function is going to get closer and closer and closer to negative 4, actually negative 4.2, but it's never going to reach that. But I know my function at this point is getting closer to that. I'm also going to graph my vertical asymptote, which occurred at 2. So I've got my horizontal asymptote, my vertical asymptote, my hole, and my x-intercept. And I know that I'm going to negative 3, so I'm going to come from that asymptote, going to cross this asymptote. I know I'm going to infinity. And here I'm approaching this asymptote. I go through this hole, and then I approach my horizontal asymptote. Go ahead and see if you can graph the other functions.